Chapter 10, Part 1, The Periodic Law. Alchemy, Alchemy, alchemy was the medieval search for a way to change ordinary metals into gold, and that process was called alchemy. Of course, it failed. There was no process at that time to change other metals into gold. Now, chemical reactions. What are they? How do we understand clearly what goes into a chemical reaction? What are the reacting reagents and what are the products? Okay, let's get started. A chemical reaction results in the formation of a new substance whose properties are different from those of the individual substances that participated in the reaction. Example, zinc sulfide as a compound. You can take zinc as on this plate. Zinc is gray. It's a metal at 420 degrees Celsius. Its density is given. It dissolves in dilute acid. It does not dissolve in carbon, the sulfide. Sulfur, on the other hand, is yellow solid. It melts at 113 degrees Celsius, does not dissolve in acid, and it dissolves in carbon, the sulfide. Now, zinc sulfide, though, having been made from a combination of zinc and sulfur, is brittle white solid, does not melt, but decompose into zinc and sulfide at 600 degrees Celsius. Its density is given. Does not dissolve in either dilute acid or carbon, the sulfide. So the three entities here are different. Although the third is a combination, a chemical combination, I might add, of the first two, it is different than the first two. Now, a substance. A heterogeneous substance is composed of separate materials of different kinds that are not chemically combined and retain their individual properties. Elements now. An element cannot be broken down or changed into another element by chemical means, as the alchemists tried to do in the medieval period. All other substances are a combination of elements. Compounds now. Compounds are formed when two or more elements combine chemically to produce a new substance. Properties of a compound are different from those of elements they contain, though. Compounds can be distinguished from mixtures by two tasks. So obviously there are compounds and mixtures. What's the difference between the two? Compounds boil and freeze at definite temperatures and are not altered by change in state. Mixtures like definite boiling and freezing points. Mixtures now consist of elements or compounds or both that are not chemically combined and retain their individual characters as the substance exists. And now you will find they are both heterogeneous mixtures and there are homogeneous mixtures also. Classification. So every substance one can see that exists in this table someplace. Matter, then there are pure matter, there are mixtures, and the pure matters are either elements, compounds, Mixtures then are homogeneous mixtures or heterogeneous mixtures. We'll have great opportunity to talk about this figure. Now, this important law of definite proportion. What is it and what's this important? Here's a case in point. If one takes 100 grams of oxygen and combine it chemically now with 80 grams of nitrogen, you will get exactly 180 grams of nitric acid. Notice now, 100 plus 180 equals to 188. If you take 100 grams of oxygen and try to combine that with 100 grams of nitrogen, you will get 188 grams of nitric acid. I'm sorry, 188 grams of nitric oxide and 12 grams of nitrogen remaining. So not all of it will combine in this process. Now, the simplest substance. John Dalton proposed the idea that atoms then are the simplest substance that exists. That is true to this day, except that the fact that there's nucleus now and there are particles in the nucleus that are also smaller. But nevertheless, this is a good picture of what elements are. So atoms are ultimate small particles of any element. The molecules are ultimate particles of a gaseous compound. So every gas can only be made of molecules. However, the ultimate particles of liquids and solids compounds may be atoms, molecules, or ions. So pay attention. Atoms, molecules, or ions can exist to make liquids or solid structures. Let's go on. These are some images of chemically combined oxygen gas, two oxygen atoms combined, ammonia molecule, four hydrogens nestled tightly with the nitrogen, etc., etc. This is an illustration of sodium chloride. This is the chlorine ion. This is the sodium ion represented as blue. So this assembly exists. There is no molecule. It's this close association that gives sodium chloride its properties. Metals versus nonmetal. Most elements are metals. Okay, that's a good point. All metals are opaque, and most nonmetals are transparent. Metals can be shaped by bending and hammering. Solid nonmetals are brittle. These are important points, so you go over and over them again. Additionally, metals are good conductors of heat and electricity, both. Nonmetals are insulators, do not conduct heat or electricity. Metal have a characteristic metallic luster. Nonmetals do not. Active elements combine readily to form compounds. Inactive elements have little tendency to react chemically with each other or with themselves. Active elements liberate more heat when they react than do inactive elements, and active elements usually form stable compounds. This is a relative table. Higher up on metals or nonmetals, these are more active, and less active are down here. Gold is the least active element on this table. Families of elements. Now, so we're getting into the idea of grouping. Elements which resembles one another in chemical behavior in the same way they react chemically are said to belong to the same family of elements. You will find elements will be in columns in the periodic table. For instance, this now. So these are called the halogens, Halogens, fluorine, chlorine, bromide, iodine, and astatine. Halogens. alkalides, lithium, sodium, potassium, rubidium, cesium, and francium. They are in group 1 of the periodic table. And the inert gases will not combine with any other substance are in the last column of the periodic table. Helium, neon, argon, krypton, xenon, and radon are those inert gases. Now the periodic law was discovered by Mendeleev, and it carries his name now. But it was based originally on uh, atomic weight, but now we know it is truly based on the atomic number. The periodic table is a listing of the elements according to atomic number, although originally I say they tried to do it with atomic weight, but now it's atomic number. In a series of rows such that elements with similar properties are formed vertical columns. And the periodic table arrange chemical families of elements in vertical columns, as I say, that are called groups. And the horizontal rows are referred to as periods. This is a horizontal row, so that's a period. And this is a column. Okay, that's a group. Okay. You will find that there are more metals, nonmetals over here to the right, and the inert gases are kind of listed there. So there are a lot more metals in the periodic table than anything else. These in the middle here are called transition elements as well. The transition elements are placed between group 2 and group 3, include the rare earth elements and the actinin series. So here, they depicted in blue here in this middle region, and at the bottom of the periodic table, both of these different groups are referred to as transition elements. Lastly, I want to talk about shells just briefly. The electrons in an atom that have the same principal quantum number n occupy the same shell. And generally, we will be most concerned with the outer shell because that's where chemical bonding occurs due to the outer shells of the electrons. And then there are subshells. So there's the shell, outer shell. So the electrons in an atom that have the same orbital quantum number occupy the same subshell. So shell, subshell. The larger the value of this, the more electrons the subshell can contain. Closed subshell. A shell or subshell that contains its full quota of electrons is said to be closed. The inert gases have closed full shells. They have the maximum number of electrons that they can have, so it's a closed structure. The electrons in a closed shell or subshells are tightly bound to the atom and not easily removed. Therefore, they will not bond, those atoms will not bond with other atoms to form compounds. Inert gases, as I said earlier, all have closed subshells and are thus chemically inactive. Okay, that takes me to the end of this presentation.